Hello guys, welcome to online course on Verilog Programming for beginner with Xilinx Design Suite. Welcome to first section. Before this section, we already have how to install Xilinx Design Suite in computer or PC, in Windows or Linux machine. So you already have installed IC Design Suite. We assume that. So in this first section, we have introduction and basic design with Verilog. So we are going to talk about how to write basic program, basic syntax of Verilog for logic gates, and how to know about operators, module, input and output declaration. So let's design a basic logic gate in Verilog in IC Design Suite. Let's open IC Design Suite. So here are some steps. Here assume you already have installed IC Design Suite in your PC. Let's open IC Design Suite. We will create basic AND gate. We will check the syntax. We will synthesize it, and we will write the simulation test bench for AND gate, and we will simulate that AND gate in Xilinx IC Design Suite with IC as default simulator. So let's move to IC Design Suite. So in IC Design Suite, you need to go to File, and you need to go to New Project, and you are going to place project name and get, and I'm just going to place, and here is project setting. In project setting, this actually signifies that which targeted board you are considering for your program. So we are targeting Spartan 3. You can select evaluation development board platform and select Spartan 3 board. You will get all the set, and here is other setting, like you not need to change anything. So let's do next, and you can do next in project summary and finish. And this is just a project folder for your project and git. Now we need to have a Verilog module, and you can place a name, any name. You can't place space in name declaration, so you can use underscore, and after that you can do next. And in the define module section, you can define all the input and output ports of your project. Actually, AND gate can have 3 total ports. 2 are input, like A and B is input, and output can be at Z. So you can select this input and output, and these all are single bit ports. Now we can do next, and we can do finish. So it will create also a basic syntax for Verilog. Now we need to include our assign statement. Actually, we already talked about how assign works. We need to assign statement and assign z equals to a, and we need to have ampersand operator and b, and this is the basic logic of AND gate. And we can save it, and we can check the syntax, and we can synthesize the design. Actually, synthesis process did the logic of checking syntax, and it will also convert this SDL audio description language written Verilog into the RTL, actually register transfer level. So it can also create a schematic of register transfer level. We can see that schematic from view RTL schematic, and we can select start with a schematic of top level block, and this is the basic schematic of our AND gate. We can even zoom, and we can double click on it. This will give us a zoom layout of AND gate in our module. This is also RTL. After this simulation is correct, we need to add another module for simulation, which is Verilog testfixture type. So you can place name different than previous name. I will just give AND gate underscore TB, which signifies for test bench, and or TF for test fixture, and this is the associate source main module of our program. Again, it will create a basic syntax for simulation test bench. Now we need to edit the stimulus, so we can update is our requirement, because AND gate will have 4 logic states, like 0 0, input 0 0, and input input 0 0, input 0 1, and we need to place input 0 1, 1 0, and 1 1. This will be the 4 logic states for AND gate. So we have comments by double slash, and which line started with S is actually the delay, which means 100 nanosecond of delay. So we can even save this. And now we are in implementation view currently, so we need to change it into simulation view. Now we can select our and get underscore TV source, and we will get simulator here, and we can again check the syntax, and we can start the behavioral simulation. This will give us the simulation waveform of our AND gate. We can verify that waveform by selecting the specific time frame. Like we can select here, actually this is 58.8989 nanosecond, which have input of A equals to 0, B equals to 0, and output also 0. In this condition, A is 0, B is 1, and Z is 0. Now we can see A is high, B is 0, and Z is still 0, because this AND gate have only output high when both input are high. So it signifies that our waveform is correct and our AND gate design is correct. So this is the basic logic of designing AND gates. Now we can design other logic gates by this method. So we will continue in our lecture session. Then after we will test and design other logic components like combination of gates, combination logic, etc. So this will be the complete gate design module in this section. So thank you guys for watching. Meet you in another lecture.